I'm Alex, and apparently, as of tonight, I'm the voice and the sight of the Astroimaging channel. They were razzing me pretty bad about my lighting and my vocals and everything else today, so I just thought I'd get them back. Now, we got some things that we're going to do today, but we're going to go through the usual routine pretty quickly here. I'm going to tell you a few things. I got to start sharing my screen, and because we got a lot of really cool stuff happening a little later on today. Not only is Randy Barron's going to be here, he's going to be telling us about sketching. And where am I? Okay, get rid of that. This is Orion time coming up. This is the title slide. And after Randy's finished, we're going to show you what you guys entered as far as the contributions about Orion. And that's about 12 and a half minutes. That's why we're kind of skimming through the rest of this stuff here. Get rid of that. This is as much as I know about sketching. So you can see that we really need some help with sketching. We were talking to Randy before the show, and he was explaining how this is a really, really good way to learn how to visualize things. And so I was putting a piece of an article together for my club newsletter of a picture I took of Hubble's variable nebula. And I realized that I had a sketch of it because, as I probably told you before, I'm a visual astronomer as much as anything else. And I sketch the objects when I'm finding them for the Astronomical League. And that's as good as I can do in sketching. After tonight, however, I will be able to do much, much better. Okay, where are we on that? We need that come up. Come on, be a good boy. Don't forget to put all your questions in over here. If you've got a question, make a big red question mark over here so we can see your questions. You can also like us and various other things and subscribe to us if you've not yet subscribed. We really appreciate you doing that. Also, you'll see down here that we now have some t-shirts for you and some sweatshirts for you, and you can get them in black and pink and red and blue and a few other colors. You can't get everything in every color, but you can get that. But join us over on YouTube and get your questions in. There will be lots of questions for this, I am sure. We've got a calendar here, and as you can see, we got a lot of good stuff coming up. We're scheduled all the way through May right now. And there's a lot of good stuff. I won't go through the whole list right now, but next week, Sean Maloney is going to be here. Sean, you're out there now, aren't you? I'm going to stop sharing for a second.
I'm here.
Yeah. So what are you going to be talking about next week?
I thought I would spend a few minutes to show you how I go about naming and saving my images during both data gathering and post-processing. Equally, I thought I would touch on how I go about transferring my files, creating folders that allow me to create a workflow that best serves my needs while using PixInsight. And then I thought I would go into some archiving and some different ways to save your data and how to make sure that you keep control of all that data and find it later on.
Okay, that's cool stuff. And we're going to need to know all that stuff. I think we got everything out of the way. I wanted to do this quickly so we'd have more time for Orion time later. Don't forget, we got lots of programs coming up, but we need more people to volunteer. And just hit that contact button and tell us that you've got an idea that you'd like to share with your fellow astro imagers. Okay, with that in mind, Randy, you're standing by ready to go, right?
You got it.
Okay, you take over now.
Okie doke. Let me get my screen up. Okay, can you all hear me?
Yes, you're good.
Okay. I have to say it's quite interesting to be invited to an astro imaging channel, but I'm real excited about it because I'm always excited about sketching and sharing it. Before I get started with my presentation, I think you should know a little bit about me. I'm a retired doctor of optometry, so I was never an engineer or an astronomer. But my interest in astronomy runs back to probably age 9 or 10. And believe it or not, I grew up in a very urban area of New York City in Brooklyn, an area called Sheepshead Bay. But I'm 68 years old, and in 1963, when I was really starting to learn the sky, you could see all the major constellations from the backyard of our house. Light pollution was so much less than it is now. So as an urban citizen, I was able to learn the sky like the back of my hand just from my backyard. If you were to stand in that spot now, of course, you would see virtually nothing. It's been an incredible change, of course, with light pollution. You couldn't see the Milky Way, but you were able to make out all the major constellations. So I've been interested in astronomy from age 9 or 10. I did do astroimaging in the bad old days of film back in the mid to late 1990s. But living in the Northeast, I felt that with the scarcity of clear nights, I was spending all my time with my equipment and not really observing. So I gave up astroimaging, and shortly thereafter, I did begin to try to sketch. I got very discouraged because I didn't seem to be getting anywhere. So I gave it up again, and then I took it up again. And this second time, I really was persistent, and it has paid off. If you take up sketching, please don't get discouraged. Over time, you will get better, and you will really become a better observer. I am amazed at the objects I look at now that I would have looked at back when I was astroimaging, and I would have visually missed so much detail that I can pick out now. You will really learn how to make the best out of your peripheral vision as well as your direct vision. And I have to stress, you do not need to be an artist to become an astro sketcher and to do sketching well. If you persist, if you try it out and stick with it, you really will see a learning curve. So what do you need to be an astro sketcher? Really, pencil and paper. We'll get into a little more of that, but I wanted to just briefly say, as you can imagine, sky gazing is probably one of the oldest human activities. And what did people do when they wanted to record the sky, having no photography, none of the equipment we have now? They sketched. And even Galileo, of course, I'm sure you all know this, did some very cool sketches. Here's a sketch of the belt of Orion done by Galileo. An interesting, nothing here about the nebula. You can see the belt stars at the top. You can see the sword stars. The middle one should be a nebula, but he has it noted only as a star. Here are some sketches of the moon that he did, which are really pretty good. One is a waning moon and one is a waxing moon. On the right, I can see Mare Crisium. I can see Serenitatis, Tranquillitatis, Fecunditatis, and Nectaris. In the middle must be Ptolemaic on the terminator, since that's very close to its position, I think. But these are pretty good. Notice how he did the darks and lights, though, with lines and stippling rather than with shading of graphite. I am sure that he did not have the available grades of graphite that we have now. In fact, he probably didn't even use graphite. He may have used ink to do these sketches. Here's a beautiful sketch done by an astronomer, British astronomer John Henry Pratt, of Saturn. And look at the detail. He's got the Cassini division. He's got the Encke division. He's got the crepe ring and the bands in the atmosphere. Look at this fantastic sketch of Mars by Antoniadi. And of course, we have the Antoniadi scale of seeing. And this is quite an amazing sketch. You might think it's overdone, but I have to say, at moments of very good seeing, when Mars is at opposition, it presents an incredible wealth of detail. Now look at this. You've all heard, of course, of Percival Lowell, the American astronomer who was obsessed with Mars and the possibility that there was a canal building civilization on Mars. Here is a sketch done by Giovanni Schiaparelli, who used the word canale, which meant channel. Percival Lowell took that and thought that canale really meant canals built by intelligent beings. But look at the map that Schiaparelli made of an incredible intricate detail, and it compares to the sketches that Percival Lowell made of Mars. And when I get to a sketch of Mars that I did, I will point out an interesting feature related to the tendency of the human eye to see lines where there aren't any, to connect dark features or spots and imagine that you're seeing lines. Here's a sunspot, beautiful detailed sunspot by Alan Miller using watercolor. I cannot imagine how he did it in watercolor. I've done them in graphite, which you'll see. But sketching has a long history. Etienne Trouvelat, I never heard of this French naturalist of the 19th century, an avid sketcher of things astronomical, and he's been immortalized with a crater on the moon and a crater on Mars that bears his name. Now take a look at this sketch of the Orion Nebula that he did, and I can see the trapezium in the very center. I have been daunted by the Orion Nebula. I have not attempted yet to sketch it because I'm also a perfectionist and I would want to get every detail. And here's a sketch he did of Messier 13, the great globular cluster in Orion, in Hercules, and I can see the star chains. He was using telescopes that allowed him to obviously resolve some stars, but nothing like the views that we get today. So let's go over deep sky. I do deep sky, I do planetary, I do lunar. I have a feeling most people here at the Astro Imaging channel would be interested in deep sky. So we'll start with that. These are the things I use. Graphite pencils. I use an H, a B, a 3B, a 6B, or even softer than 6B. H, hard, B for black, are softer pencils. The higher the number in B scale, the softer the pencil. I use H and B and 3B for stars, H for the dimmest stars, B for mid-range, 3B for the darkest stars. 6B I use to get the graphite that I spread for nebulae or galaxies. Red lights, of course, because you want to remain as dark adapted as possible. I use light clips red lights that I clip to my board, which I'll show you. Very valuable, of course, are erasers, not only for making mistakes, but the first thing I have listed, a kneaded eraser, looks like a piece of silly putty. And you can shape that eraser into a point or into a wedge for a straight line. It's an invaluable tool for helping to shape the graphite that you spread on a paper to represent a galaxy or a nebula. Blending stumps are used to spread graphite. I'll show you a picture of those soon. You can get them at any art supply store. Compass and straight edge, drawing or sketching paper. I've used even computer paper, just plain white paper. I like sketching paper because it has a tooth to it, which holds onto the graphite. And when you're spreading it with a blending stump for a nebula or a galaxy, the sketching paper holds it better. Here's an image of what I'm talking about. There are the three pencils I use the most, an H, a B, and a 3B. I do use softer graphite, as I said, to spread graphite for a nebula or galaxy. And the light there on the very bottom, I got on Amazon. It clips to your board or your whatever you're using. It's red lights, and it's used mostly by musicians. I find that the light is, even with that, is still a little bit too bright, and I dim it down just with a layer of masking tape over the bulb. These are the blending stumps I was talking about. They're really rolled up paper, very tight. You can sharpen the ends, you can dull the ends, so that you can you have such flexibility with spreading graphite with these various blending stumps. Absolutely invaluable if you want to take up sketching. So I'm going to skip over the lunar for now. And if we have time, I can go into lunar. You might want to have another program on that if it interests you. I want to concentrate on deep sky. This is, again, briefly, the scale of graphite. Again, grading in pencils. H, hard. B, black, soft. I find that the H pencil is perfect for doing dim stars. I find the B grade is excellent for mid-range, and I find the 3B perfect for darker stars. Now, many sketchers say they only use one pencil and they can vary their pressure to increase magnitude or decrease magnitude of a star. I find it's much easier for me by using the 3 pencils. It's not a lot. I just keep them handy right in front of me by a clipboard, and I'm ready to go. Again, the blending stumps, compass, pencils. I want to talk about how I start a sketch. What I do is make a circle with the compass, and I make the face of a clock with markings along the circumference. Those markings I label 1, 2, 3 o'clock, 4 o'clock. That really helps me place the stars accurately, or as accurate as possible, because even in sketching a nebula or a galaxy, you really want to have the background stars to help you place it properly and to help you size it as well, because you'll reference it to the background stars that you've placed. So I draw a circle with let me just talk about this. To get the graphite that I will use for spreading, for doing the ring nebula, which is what I'm going to start here in this little program, I spread the 6B out on just a piece of scrap paper. And from that well of graphite, I will pick up that with a blending stump and use that to create the nebula. So I've drawn my circle. I use around 6-inch, sometimes a little bigger, depends on the object. And a very easy way to make the face of a clock, draw a line anywhere along the circumference of your circle. Pick up the compass, keeping the same radius. Put the compass, line the point with the mark you just made, and then mark out arcs, successive arcs along the circumference of the circle in equal to the diameter, the radius that you used for the circle. Very simple. So here I have my arcs are made, and now to divide those arcs in half, so I will get the face of a clock. If you guys and ladies remember your high school geometry, you remember how to bisect a straight line by using arcs. Well, I attach the compass to one of the points I've made, and I draw an arc, and then I draw another arc from another point, from the point preceding. I think you can see how this is done. Where those arcs intersect, drop a straight line towards the center of the circle onto the circumference. Then take your compass and draw again a whole set of marks along the side, but starting from where you dropped that perpendicular to the circle. So you really will be creating the face of a clock. So I've done that. You can see in this image, you can see the 10 and the 11 position. Now, I can't do a telescope for you guys, but here's an image, a beautiful one, of the Ring Nebula. I'm pointing at some of the field stars. Notice how I've lined it up with about 8 o'clock, 8:30 or so on the side of the circle. So I'm beginning to put in my field stars, referencing them to the circumference, the face of a clock that I've drawn. Once you get this going, it becomes easier and easier the more stars you put into your area. When you've got enough stars, and usually I work from the outside in towards the object. When you've got a number of stars plotted, you can then start looking at how stars relate to each other. Do they form little triangle patterns? Do they form little parallelograms? And with that, you can add dimmer and dimmer stars. But you determine in any sketch you do how many of those background stars you'd really like to include. So here again, I'm adding another reference star, another star in the field. Then I pick up graphite with my blending stump once I feel that I have enough of the reference stars. And I begin with the ring nebula to gradually sketch with the graphite. Now, the little spot in the center is really the mark from the compass. I held the compass too hard for this. Normally, I would put maybe another piece of paper underneath the paper I'm drawing the circle on, or later I can get rid of that spot using a program like GIMP. Now, in that photo, the ring nebula was right in the center, and that's very easy to place. Sometimes it may be difficult to figure out how to place your deep sky object, in which case just find a bright star for the center and don't worry about the object possibly being off center from that center star. It kind of makes for artistic interest not to necessarily have your deep sky object in the center. So many times I will find a star for the center, and then the deep sky object will be off to the side because it was just easier to do it that way. So one of the easiest things to sketch as a beginner sketcher would be open clusters, because it's really only a matter of placing stars with reference to the circle you've drawn, the face of the clock that you've drawn. Open clusters are beautiful. Many deep sky imagers, I think, don't pay attention to open clusters. I find that each one is different. They differ in terms of how concentrated they are. They differ in terms of the range of stellar magnitudes within the cluster. And they differ, of course, in terms of how concentrated the clusters are. So let me show you some examples of the open clusters that I've done. So Messier 44, the beehive cluster, this is visible very easily, naked eye object in a dark sky, barely visible in a suburban sky as this one was done. This was done when I was living in the Huntington area on Long Island, so a suburb of New York City. Messier 44, if you have a wide field eyepiece to get a wide field view, is really quite beautiful. It's one of the closest open clusters to the Earth at only 2,300 light years away. And interestingly, it may have been noticed by Aristotle back in 325 BCE. So here's my sketch. Here's a photo. And here they are side by side. And if you look, you can see, now my sketch is not rotated to be exactly the same as the photo, but a look at them and you will see that there is, I think I captured it. And this is an easy target to start with. And I would recommend starting with open clusters. Again, going back with this cluster, M40, going back to the beehive cluster, M44, you notice that I put in little hints of color. That I did with GIMP. You'll also notice the little spikes on the brighter stars to kind of imitate diffraction spikes. With pencil, with H pencil on the original sketch. Sometimes I even put a little bit of shading with graphite around the star. Now remember, you're doing this in graphite. You're going to image reverse this so that the black becomes white. So the sketch, of course, was done with black pencil on white paper. Image reverse, you get this, you'll be amazed at what it looks like when you flip the image and you make a negative. So again, let's move on to this one, Messier 41 in Canis Major. It's another object that you can see in suburban skies. Notice how bright my background is here. So once again, I did this with graphite on white sketch paper, and I image reversed it in the computer. Now, to get the the suburban sky that you see, the light is really a very bright sky. Messier 41, of course, being Canis Major, is in the southern sky, which was even more light polluted from my location. I used the program GIMP to add more light to the background. It's a very easy skill to learn. If you ever wanted to invite me back, I could certainly do a tutorial on how you could use GIMP to do that. But I did really want to represent this cluster, showing how bright the sky was that I was working with in doing this cluster. Here's what it looks like in an actual image. Look at the background stars, so many that were missing in my sketch because, again, I was doing it in a very light polluted sky. I have had the opportunity to see this in Borrego Springs, California, which is a much darker sky, and it's just absolutely beautiful cluster. And I will attempt to do it in a dark sky. You can see the difference from how my sketch is in that very light polluted sky. This is a beautiful cluster also in Canis Major, NGC 2362. I did this in Sarasota, another very light polluted sky. It's a cluster around the star Tau Ceti, Tau Canis Majoris. That's the very bright star in the center. To me, the cluster looks almost like fireflies floating around a light or a fire. It's a really beautiful cluster. Now, I did the haze, the glow around Tau Canis Majoris with graphite. The rays I did on GIMP to, again, indicate how bright that star was compared to the stars within the cluster. Now, the bright star, Tau Canis Majoris in the center, is a true member of that cluster. And if you haven't seen this one, I would recommend taking a look at it. I've also seen this from a darker sky as well. And again, it's a very beautiful sight. This is the actual cluster, a photo of the cluster around that amazing bright central star, Tau Canis Majoris.
Randy,
yes.
Do you have a chance for a question here?
Yeah, sure.
So are these sketches, do you do the sketches from images, or are you watching the telescope and sketching as you go?
Right at the telescope, right at the scope.
And how much time do you usually take to do an image?
A sketch like this at the telescope would probably take about 45 minutes because I'm very particular in how I place the stars. Now, let me just backtrack. It's a good question. I do all this at the telescope. The dim red lights I showed you, the clips to my clipboard where my paper is. Remember, again, it's the white paper. I have the image. I drew a circle, and I have the numbers of a clock face around it. I get rid of all that when I flip the image on GIMP, when I reverse it to a negative. I create another layer where I can create a mask, so I get rid of the circle I've drawn. I even feather the edge of the mask a bit to kind of simulate the eyepiece view, but I do this all at the eyepiece. And then I flip the image on the computer in GIMP. So again, remember, you're doing it in graphite. You're doing it in black on white, but you will reverse the image. And the reason, again, I recommend starting with an open cluster. Once you do an open cluster and you flip the image, that's just a great reward. And that could really help encourage you to keep up with the sketching. So yes, I do.
There's one more question. George
Yep.
asked a question. Do you know of any artists that do the same kind of thing but use color in their sketches?
I don't know of names in particular, but I think the best website maybe for finding an answer to that is Cloudy Nights, because there are many forums on the Cloudy Nights website. And I have seen sketches done actually with watercolor. So that might be a good resource for finding information on that.
Now, if you do watercolor, then you'd have to know what the inverted color is in order to invert and get a black sky out of it.
I would imagine with watercolor, you're doing, I don't know how you do it. I really, and I can't even imagine using watercolor at the eyepiece. In dim light, I couldn't see how it can be done, but I've seen it. I've seen some interesting stuff.
Wouldn't it be, well, I guess some stars have color enough to do
Yes.
it.
Oh, yes.
But it would be mostly the planetary stuff.
Yes. Yes. But when you really are observing open clusters and you're sketching, remember, it is going to make you a better observer. You will really start to see star color that you've never seen before. The subtle shades that you really begin to see. Trust me, do it and you'll start sketching and working with open clusters where you get to compare the colors in the same cluster. You'll really begin to see color.
If you get a chance to travel to the southern hemisphere, we have a star cluster called the Jewel Box. And
I would love to see that.
Its name does describe the object. I've never seen so many colors and stars visually with that. It's impressive. Even from the city, it's colorful.
Yeah, that's what clusters really provide, that opportunity. So here's another open cluster, 2266 in Gemini. It's about 11,000 light years away. You cannot see this at all in a light polluted environment. It's impossible. In a dark sky, it's this beautiful spread of stardust in a sort of a triangular shape. It's a beautiful object to sketch. Now, you might, if you're taking up sketching for the first time, you might not want to do something like this because, again, there really are so many little stars to sketch. So I would stick with, if you're first starting, I would stick to the less complex open clusters. They really do provide an excellent way to begin sketching and to see how once you flip the image, how good it really looks. This one I did in Borrego Springs. Again, against a dark sky, this is a beautiful cluster. I had tried to see this in light polluted skies, and I thought, what is this? I don't really see anything. And once I used my Celestron 11 in a dark sky, it was amazing. By the way, I use two telescopes. I have a C11, and I also have an Obsession 15-inch ultra compact. So this is the same cluster, again, 2266 in my sketch. And here it is in a photo. And you can see the triangular shape and the spread of little stars in the center. And color. I did not put color into my sketch in that one, but I do recall seeing the colors. Another thing, you really ought to take notes when you do a sketch. I do that as well in a little spiral sketch, a little spiral notebook. It helps me when, in terms of color or something that I might want to modify when I finally finish with the sketch. Here again, comparing the two, NGC 2266 in Gemini with an actual image. You can see, again, it's not rotated at the same. If you look at the little arc of bright stars on the bottom in the photo, you can see in mine it's shifted a bit because to rotate it to get north at the top and east on the right. But you can see it's fun. This is a cluster I did in a very suburban environment. This one, when I looked at this, and it's in Lacerta, the Lizard, very small, dim constellation between Pegasus and Cygnus. I was struck by the blueness of the stars in this, and I had to try to reproduce it in the sketch. What I did was I used colored pencils to try to get some of that color. If you're just starting out, don't even bother with the color. You can do that later on when you get better, or you can try doing it on GIMP if you have your notes and you want to do it. But this one struck me with the blueness of the stars. And again, so light polluted, hence the sort of gray background. And I don't have many background stars because they just weren't apparent. But when you see the photo, you can see what the area ought to look like in a darker sky. Obviously, you wouldn't see all of those, but you'd see many more than I saw in this sketch. But again, I really did love the sketch. The blueness was so apparent. Young blue O and B stars. Again, side by side, I can see the little triangle in the sketch, and again, have to be rotated to fit the actual image in the sky, the actual image from the photo. A pretty little cluster. This would be a good one again for someone to start with. This was one that, again, in a light polluted sky was nearly invisible. NGC 7510 in Cepheus. It's pretty far north. It's actually pretty close to the North Celestial Pole. This is where the stars were really unresolvable in my C11. Sorry, I don't have the info on this one on the page, but it was with my Celestron 11 in Borrego Springs. You're struck with basically a mist of stars, and I used graphite. I got my stars as close as possible, and this took a long time because you can see there are a lot of background stars. Got the stars as close as I could, as carefully as possible, in order to frame that little mist of starlight. Unresolvable. I could resolve some of them, kind of like a globular cluster, but it's the distance to this 1,400 light years. So it was not possible to really resolve the stars. But I love seeing, I love the spread of starlight like that when it's unresolvable. Here it is. You can see how many stars are involved in that cluster and why I couldn't resolve them. I bet in the Obsession 15, I would resolve many more stars. So globular clusters, that's a tougher target. Again, I'd recommend starting with open clusters. So how do you even begin to go about doing a globular cluster? Actually, not in too many different, the techniques are really very similar to open clusters. You will make your circle. You'll set it up like the face of a clock. I would definitely, in the telescope, put the glob in the center and in the center of my sketch. I work from the outside in, and I put in the bright stars to help me begin to frame the glob in the middle. I would take I spread some graphite out, and I'll take one of my blending stumps. Let's go right to the first Messier 5. I would use the blending stump with graphite to very lightly put in the shape of the glow from the glob, very lightly. And that helps you to begin to frame the stars of the globular cluster. I look for whatever stars are very bright and resolvable, and I place those as carefully as possible. I probably will use an H pencil for that. If they're slightly brighter, like for M5, I might use a B, very light pressure. Once I have in some of the brighter stars, I use a speckling technique to get as many stars as possible, the sense of graininess you see in a glob. What you're trying to do with a globular cluster that gets totally washed out in a photo, you're trying, I think, to show the individuality of each globular cluster. When you look at photos, they all almost begin to look the same. When you sketch them, you look at in the eyepiece, they have different characters. They have different configurations of star chains that lead out from the globular cluster, different concentration of the core. Sometimes you can see some detail within the glob of like a dark lane. These are tough to do. There's no doubt about it. And I wouldn't recommend starting with globular clusters, or you really might get very frustrated and not like what you've done. So again, briefly, the steps that I would do for this, what I did do, I had my circle. I worked from the outside in with brighter stars that I could resolve. Again, my circle had all those notations along the side like a clock, which is extremely helpful. I shaded the shape of the glob with graphite that I picked up on a blending stump very lightly. And then I tried to fill in whatever stars were really definitive. And that is very time consuming, but it really pays off. I concentrated on the star chains. To get that graininess of unresolved stars, you spend quite a lot of time speckling with an H, or even something harder than an H, maybe a 2H or a 3H pencil. What you might want to do is try speckling inside under light in comfort with a glass of wine. That might help. It seems then if your family member comes along and sees you're drawing dots, just blame it on the shutdowns. But indeed, it is a technique and it works by speckling. So there is the picture of M5. Where are the star chains? They're disappeared. The nucleus, I mean, it's incredible. It's an amazing and gorgeous object, but its identity in terms of its individuality with the star chains and the glow from the glob disappear in the photo. And I did not know this. Just an interesting fact, since this is an audience of astroimagers, though I intend to look at this. Messier 5 is superimposed on an edge of faint cloud of galaxies, 200 galaxies per square degree. And I looked at the Pocket Sky Atlas from Sky and Telescope, and indeed, just a few degrees west of M5 are all these galaxies, NGC 5846, 5850. I'm going to take a look. It would be great to see some astro images of these, but I didn't know about this, so cool little fact. Messier 13 from Borrego Springs. Again, notice the star chains and the way the greatest concentration is shifted a bit within the glow. And you've got some areas of no stars, seemingly no stars within that glow. Again, a glob is very time consuming. What you concentrate on are the star chains and the stars that are very resolvable. The C11 gives you an amazing number of resolvable stars. You don't have, I think for a glob, you really don't have to be 100% accurate where you put these resolvable stars. And then, of course, as I said, you speckle with a very hard pencil. And when you flip that image, you will really be amazed at what you see. You'll look at it and you'll actually see that if you look off with averted vision, you're seeing more stars, which is coming from your speckling. You really did make stars that are just at the just barely resolvable, and that you can see better even from your sketch when you look with averted vision. But M13 is also very close. There's a picture, a photo of M13. I can see some of the star chains, but again, going back to my sketch, the star chains are more prominent in the sketch. Interesting though, remember this is not exact. I mean, you're trying to be as exact as possible. Don't beat yourself over the head if you've missed something. This is for making you a better observer and just a very satisfying aspect to the hobby. And again, you're doing something that all the first astronomers did when you pick up that pencil and you begin sketching. So Messier 13, I've always wanted to do this. I finally got to do it. In the same eyepiece field, I got the Galaxy 6207, which you can see to the right. I probably didn't do as good a job on the globular cluster itself, but I really want to get that feel of the galaxy, which is 30 million light years away, versus M13, which is 25,000 light years away. Another thing I didn't know, maybe many of you out there do know this, in 1974, they broadcast a signal from the now defunct Arecibo radio telescope in Puerto Rico towards Messier 13. And it was a signal that had information about DNA, the human species, the location of the solar system within the Milky Way. But what I've often wondered when I read that is, we know that globular clusters are in rotation around our galaxy. Will this, in 25,000 years, when this signal reaches Messier 13, will that globular cluster even be close enough to a point in the sky where it'll intercept that signal? I don't know. But I love this juxtaposition of the glob and the galaxy. Now, you can see some graininess in this picture. I believe when I did this sketch, I used a sketch paper that had more tooth to it, and it was virtually impossible to get rid of it when I flipped the image and made the negative. I'm fine with it. It's okay. It just was an easier sketch paper to work with in terms of smearing graphite. But probably could have done this on a better paper, and maybe I will. Here's a picture of the glob, Messier 13, and the background galaxy. Let me see, going back, I think I did get a hint of a nucleus in the galaxy, but it's no detail. It's an edge-on small spiral, but I'm not sure. But I love that juxtaposition of the two in one eyepiece field. So globulars are a tough thing, and I would not recommend that for a beginner, but you can do it. If I'm not an artist, and if I can do this, I really believe anybody who can draw a dot and smear some graphite can learn how to sketch. So I think one of the things astroimagers love, I love looking at the images, are of course galaxies. And I find that galaxies, in terms of sketching, require you to require a dark sky for sure, so you can pick out detail. Let's go to my first slide. So this is NGC 4565 from Borrego Springs. Again, remember, it was done with black on white and then image flipped. You see the dark lane in the galaxy and the slight where the bulge is, and above the dark lane, there's a little faint glow. That's the glow that's hardest to see on that side of the galaxy. We'll look at a picture soon. But the way I did that dark lane, you may remember I mentioned the kneaded eraser. It's like a piece of silly putty. I should have had one to hand, and I don't want to leave to get it. But it's like a piece of silly putty, and it's called a kneaded eraser. You can knead it to a knife edge and pick up graphite gradually to make that dark lane. Remember, you're going to invert the image. So to get the dark lane, you actually have to remove some graphite. And I used a straight edge and put the straight edge against the kneaded eraser until I got truly a knife edge. And I worked with that to create the dust lane that makes this galaxy so beautiful to look at. Edge-on spirals, of course, are absolutely beautiful. The photo, you can see that dark lane. You can notice that if you look at the bulge in the center above the disk, the dark lane is a smaller glow. That's much more difficult to see. But again, with the skills you'll acquire from sketching, that might become easier for you to pick out. And going back, I definitely was able to see it and record it in my sketch.
Randy?
Yes.
I have another question. You probably know what this object looks like from all the pictures. Are you ever influenced to see things there?
I really try not to. I have to say that.
I mean, if you know there's a bulge there and you know it's a dark lane.
Yes, but
you want to see it.
All you can do is your best to go with an open mind. And if you really don't see it, don't put it down. But this was a C11 in a very dark sky. So I really was able to see that very faint light of the bulge on the side where it is more difficult. There was something else I wanted to say about this one. Yes, but what I am doing now to really avoid that is I am picking things at random from that sky atlas with the Obsession 15 and seeing what I can see. And these are things that I have never looked at, obscure NGC numbers. And that provides a real blank slate for me to work as a sketcher. So there again, we have the image of 4565. It's one beautiful galaxy in Coma Berenices. So,
Randy,
yes.
while we've got you interrupted here, we've had a few questions pile up. Is it okay if we ask them now?
Sure.
Eric, you were having a discussion about color with Chandrasekhar.
Yeah, it was kind of a chat over on YouTube rather than questions. But yeah,
Well,
so the question really came up about inserting color, and do you do that, or do other people do it, or is that something that is kind of beyond the realm of? And the question came up about nebula, about seeing color.
Yes.
And as far as I know, there's only a couple nebula where you can see color, M42 in the ring, where you can visually see color.
Yeah. What I will do, since again you're just you're flipping the image, if I really want to add color to a nebula, I do it using GIMP, and I do as little as possible because I don't see very much color. Not at my age. I really see very little color. I definitely see star color, but I really don't see too much color in nebula. In the star colors that I pick out, I reverse the image, and then on the reversed image, I might either print it out and play with color, make several copies, and see if I'm happy adding color that way using my notes. Very important to keep notes when you want to add color. Or I will do it with GIMP on stars. With nebulae, I really see very little color. So you'll see a couple of planetaries I did add color. There were two that I have which are just spectacular for the visual observer, which we'll get to. And I did add color, but with those I used GIMP. I used some processing to add the color and to keep it as subtle as possible because, of course, I don't see anything like what the astro images show. Being an optometrist, I can tell you the way our retinas are set up, our night vision, you're using rods, the rod cells on your retina rather than cones. And rods are meant to fire under dim illumination, and they are not meant to discriminate color. The cones on the retina, you have 3 cones, each responding to different wavelengths. And the cones are what you use for color perception. During the dim conditions that you're working under, you're using your rods, and those cells just don't really pick up color. The little color you see, you are getting with the cones, but I really don't see very much color. I don't know if that answers the question. But anyway.
Randy?
Yeah.
You use the term speckling and stippling.
Yes. Stippling,
and
yeah.
you know what those mean. I'm not
Yes.
sure that I know what they mean.
Okay. You take a pencil in stippling and you just keep dotting one small area with the pencil over and over and over again.
And it's not necessarily saying there's a star there and a star there and a star there.
Exactly. You're just doing this, trying to get that graininess that you get in a globular cluster in the core.
Okay.
And
And
you're making,
stippling.
yeah, stippling, and you're making them as faint as possible using a very hard pencil. You'll barely see them on the paper. Yeah.
Is it stippling or speckling? Where's the word you were using?
Stippling should be. I meant to use stippling. Yeah.
Okay. So lots of dots to tell me, oh, there's lots of little stars there.
Yes.
But not necessarily in the place that they are, in fact, there.
You can't.
That's called stippling.
Yes, you couldn't.
Because I gotta know this stuff for if somebody asks me about how to sketch.
Okay,
Yeah,
so
right.
you use stippling. There's no way you're going to get all the stars that you can. When you look at a glob with averted vision, all of a sudden it just blooms with stars. It becomes incredible. You can't. There's no way you can do that. When you're doing a glob, as I said, I think what you're concentrating on are what really makes that globular cluster unique or characterizes that cluster. the star chains coming off, the position of the nucleus, whether the nucleus is really resolvable or not. I don't have a sketch here on this program, but you can look at some globs that are very dim. I have posted them on Cloudy Night where no stars are resolvable, and it's just a glow that you'll try to place as accurately as possible with the background stars. And that's a pretty thing to look at as a sketch. You'll use the graphite that you pick up with your blending stump and just place what you're seeing in a small little glow correctly as you can with respect to the background stars. Globulars that are too far away or that are too small to present any resolvable stars. But it's still very interesting to do that and placing them accurately with the background stars, and you produce a very pretty sketch. This galaxy, we all know, Messier 33. I did this from Corn Springs, which is as you can see, I put the SQM-L reading of 21.95, a very dark sky. This has been, this is virtually unchanged from the image. I simply just flipped it, and that's what you're seeing. I was able to make out absolutely 2 spiral arms. I was able to make out NGC 604, that if you see the spiral arm that's up to the top, rotating off to the left, at the end is a little bright spot. That's NGC 604. No. Yeah, 604, which, by the way, if that little region that looks so tiny, it's of course a star-forming region. I'm sure some of the listeners and viewers have imaged this galaxy. It's been imaged over and over again. And yes, did I have a preconceived notion of this? I tried really to get down what I saw as best that I could. Anyway, NGC 604 at the end of that prominent spiral arm at the top, if that was at the distance that the Orion Nebula is from the Earth, that would be the brightest object other than the sun and the moon in our night sky. It's such a tremendous region of star formation in that galaxy. I have no doubt I saw the 2 prominent spiral arms, and the longer I looked, the more sure I became that I saw some detail off those spiral arms, picking up maybe 2 other spiral arms. The core to me is not very impressive. It's very subtle, but this has been imaged over and over and over again. I had never sketched it, so I had never made an attempt to sketch it. I really wanted to see this in a dark sky. I'm sure viewers know that if you try to see this one in a suburban location, you will be severely disappointed, even if you have a very large aperture telescope. In a dark sky, man, does this thing jump out at you. And you, without any doubt, and even the C11, I have to do another sketch of this using the 15 in a Bortle 2 sky. This thing just jumped out at me, the eyepiece. NGC 604, just no problem seeing it, no averted vision. But with averted vision, I could fill in some of the detail very softly with the graphite. You can't get it 100% smooth. You'll always see some graininess. You could process it. I really didn't want to process this. I tried to just show what I sketched. You can see the spikes I put in myself with pencil. They're a bit wobbly to show the brighter star off to the bottom. A beautiful sight. Of course, here's a photo. It's a magnificent structure. But, you know, I can see from the sketch, why it's called a pinwheel. It looks more to me like a pinwheel here than it does here. Here it looks like a whirlpool. And I know we use the whirlpool to talk about M101. Of course, it is said that you can see M33 with the naked eye from a dark sky. I have never seen it with naked eye. I'm wondering if any of the viewers have. Now, it could be that being 68, my eyes can't make out that kind of an object. Of course, in the dark sky, Andromeda just pops right out at me. I've looked and looked and looked, and I can't even know exactly where it is. I can't see it. But supposedly the most distant object that can be seen with the naked eye, for me, it's the Andromeda Galaxy, which I believe we have next. Yes. I did this from the Goat Mountain Astronomical Research Station. I try. Andromeda is just almost impossible. It's so big to fit into an eyepiece. So I knew I couldn't do the whole thing. What I wanted to get was the galaxy with its two satellite galaxies. Messier 32 off to the upper right, and NGC 205. I think Messier 110 is also used for the designation. I just barely got part of that into the field. But I did see the two dark lanes in the front. One was very prominent. The outer one was more difficult to see. And I also put some graphite behind the galaxy, very slightly. You can see running through one of the little faint stars. If you look to the, you go to the nucleus and you look to the upper right of the nucleus, very faint smearing of graphite, because I was seeing something of a dark lane and more of the galaxy wrapping around behind, as you can see in the image. Of course, the image, it's magnificent. You can see how enormous this object is. And when you see an image like this, it's M32 looks like it's within the galaxy. It's so close. It's within the galaxy glow. Going back, there's no glow between M32 to the upper right and the galaxy. But this will come in very useful, this sketch. I would have to print it out because I wouldn't want to show it on any illuminated device at a public viewing. This would come in great use at a star party, showing the public what to expect, because they will not see this through the eyepiece. They will see this, much more subtle, much softer. And I've done this with another sketch that was not as good as this, that I used at star program at Anza Borrego. And it really was helpful because people really, so many people have seen images, photos of the Andromeda Galaxy. And when they saw the sketch and looked into the eyepiece, they said, that's really close to what we saw. And it wasn't even, I think, as good a sketch as this. But the sketches really are helpful for what people will see. Many people can be disappointed because all they've seen are spectacular astro images, and they look through an eyepiece, and other than the globular clusters, which look magnificent, things like galaxies are much more subtle, and nebula, other than super nebula like the Orion Nebula, most nebulas will be much more subtle. And try to do it with a nebula filter on the public, and probably they'll see nothing.
Randy,
Yes.
A couple more questions.
Mhm.
Matthew asked, have you ever used Bristolboard for sketching?
No, I have not.
And the other question is, you wear glasses. A lot of us do.
Yes.
Do you actually focus out of the telescope, or do you have astigmatism?
Oh boy, do I have problems with the glasses. I have astigmatism, also, of course, presbyopia, meaning I can't see up close. For the distance, the astigmatism is so slight that my focusing without the glasses is fine. I can do that. But do I have to fumble back and forth between the glasses and the sketch when I'm sketching. What can I say? It's a hassle, but I put up with it and I do it. Someone who's a full-time glass wearer, most people seem to do well taking the glasses off and focusing through the eyepiece. Certainly if they're myopic or hyperopic, they farsighted or nearsighted, they can just focus the eyepiece. But for me as a sketcher, going back and forth between the eyepiece and the pad, it's a hassle, but I do it. The glasses are there. I try not to drop them, and I just switch them on and off. And it takes time, but it's worth the effort.
Can I ask how much more you have to present?
I can go not that much, but let's move on. I'll talk about this one. This is a galaxy pair that I never saw before, so I had no preconceived notions. This is a pair of interacting galaxies. You can see the smaller one, there's like a soft glow moving out from it, and look at the picture. I didn't look at a picture until I had sketched it. I think I nailed it. I got this interacting pair of galaxies. This is NGC 1532 and 1531, also called Halley's Coronet, which I never knew. And they are 58 million light years distant. So again, the sketch, and again, the actual object. One more galaxy, and the two more, NGC 2683 in Lacerta. No, not Lacerta. Near Cancer, near the constellation Cancer. I had never seen before. I knew that in using the 15-inch obsession out in Wonder Valley, which was like a Bortle 2, I could make out a dust lane, which you can see very faintly to the right of the nucleus. And the picture of the galaxy, there is a dust lane there. This one, NGC 253, the Sculptor Galaxy, filled with detail, glowing knots, dark areas. This I did with a C11, and I was under a time constraint because this is a far southern object, or it's in pretty far in the southern sky. There were trees in the way, palm trees, that were going to interfere with my vision, so I had to sketch this one as fast as possible. There's an image of NGC 253, a magnificent galaxy. Another pair I had never seen before, 4088 and 4085. Absolutely saw the spiral shape with the 15-inch obsession. Aperture in a dark sky really pulls in amazing detail. The photo, you can see, again, I had never seen this before. So this was done with no preconceived ideas of what I was seeing. And that was great. You can imagine how I felt when I saw the photo. It was pretty good. This one as well, I had never seen, NGC 247. It's also called the Needle Galaxy for obvious reasons. There's a dark area, the very bottom of the galaxy. You can see a void that is actually a void in the galaxy. I had no preconceived notion of what this looked like. And here's an image. You can see that void. Again, done with very softly, very gingerly with the smeared graphite. You apply it very softly. You don't want to put too much. It's harder to remove than it is to put it down. And again, this was not in any way changed, just image flipped, and that was it, really. I had added the glows around the bright stars with graphite. Oh, Messier 77. I had never seen detail in this. Now, yes, I had seen photos, but I'd never seen it through the 15-inch, and I'd never seen it really in a dark sky. And finally, I was able to see that this is indeed a spiral galaxy, the picture of it. It's a Seyfert galaxy also, with a prodigious black hole in the center. So it was quite a thrill to actually see the spiral structure. This I did some years ago in Huntington, M82, a very light polluted sky. My stars are a mess in this, but with an ioptron, a smaller scope, I was able to pick out the dark lanes that bisect Messier 82. Here's a picture. Of course, I think it was 2014, there was a supernova. I did get to see it from Sarasota, Florida in M82. That's it for the galaxies. Nebulae, again, you will apply softly with, very interesting. Alex had shown us the Hubble's Variable Nebula. Here's a sketch that I did in a dark sky in Sarasota. That's about 20 miles inland and in a dark area that a local club uses. This was one that I worked on for probably an hour and a half to get it right. I kept putting graphite down and taking it off. And I did have a vague idea what this looked like, but not in detail. And here's a photo. So again, pretty close rendition of the Hubble's Variable Nebula. Here's where I added color using GIMP. NGC 1501, it's also called the Blue Oyster Nebula. This was a wonderful planetary to work with a C11 in a dark sky out in Wonder Valley, which is east of 29 Palms. I absolutely saw the central star. I had never seen this in a photo, so I was doing this completely blind. And the color I added a very slight color with GIMP very carefully because I took notes and I tried to match what I saw. I think this is a good match because, of course, I looked at it again, and this is the color I saw, a very faint blue. Look at the detail in this planetary. I love the explanations of magnetic fields for producing this. To me, it's just unbelievable that these structures exist. This is a wide field view of the same nebula. Here is a 1535 that I had never seen. It's called Cleopatra's Eye. This is a dark sky, Borrego Springs. I think I added some color. I don't see any color in this, but maybe I added a little bit of blue because it is very blue. That's the actual image. Again, my sketch of Cleopatra's Eye. Again, I had never seen it. I know I saw the central ring, the central star, and faint detail around it. I did not see a sharp end to the glow as shown in the photo. I saw a much more subtle end to the glow, except on one side, I was sure I saw a sharper demarcation line. But in the photo, you see the outer cloud just ends. Wider field view of Cleopatra's Eye. The Running Man Nebula, I just did this. No, it should be February 2021. I just did this. Guess what? I forgot to change the year. I put 2020. I just did this of the Running Man Nebula, which is just north of the Orion Nebula. To the lower left, you see a little bit of a haze. That is M43, the one that's next to the Orion Nebula. You see the grain again? Again, I used a sketch paper that had too much tooth. And there's virtually no way to get rid of that. Here, I brightened it on GIMP so that you really could see the image that's called the Running Man. You'll see it in this. This is an actual image. North of the three stars, the three bright stars, is dark nebula, creating this impression of a guy running with his arms outstretched. Back to the sketch. This is the true what I saw. This one, you've got to have a dark sky. You can't really see it in a suburban sky. Filter is of no use because it's mainly reflection nebula. I also found with the two planetaries I put up that filters were of no use as well. Crab Nebula. Yes, I've seen it a million times, but I'd never seen it in a dark sky. And this is what I did in Borrego Springs using my C11. And the image, not too bad. Again, the sketch and the image. In a dark sky, finally, I was able to make out some sense of internal detail rather than just a soft glow. The dark sky makes all the difference in the world. Aperture, yes, but dark sky more. Double stars, carbon stars, I'll quickly go through these. You might have no interest in these. Obviously, with double stars and carbon stars, I'm going to add the color with a program because using graphite, you're not able to do it. This is, which star is this? It's a double star. This is Akkerd, I think is the name. It's Eta Cassiopeia. A very nice colorful double because you've got the reddish star, much different in magnitude compared to the bright central star. And this is, it's called H3485. It's also known as the winter alberio. You can see why. H3495. It looks just like alberio. Another doubles, a carbon star, WZ Cassiopeia. I did this full moon in a suburban environment in the New York City area. There are so many stars, background stars, it was just a beautiful sight. Carbon star, of course, deep red from the carbon in the atmosphere of the star. Beautiful stars to image, I'm sure. That's an actual photo of it. Sketch I did of Jupiter. You don't need a dark sky for planets. Colored pencils. A double transit of Jupiter. The reason the background is so bright, it was twilight when I did it, and I wanted to try to represent that when I actually finished the sketch. Two stars. I love the fact that the shadows were so far apart. And I love the fact that I was able to get some detail, seeing detail within the bands and the festoons. You can download this Jupiter template from the Association of Lunar and Planetary Observers. It has faint shading on it that has the equatorial belts and bands and zones. So you got this template. It really makes it easier to start to do a sketch of Jupiter. Mars, this was just excellent seeing when I did this sketch of Mars. And I wanted to mention this. You notice the lines that look straight on this. I saw that. That is the visual impression that I had. The dark area on the bottom must be Syrtis Major. And I finally understood many of these observers could have been tricked into seeing straight lines and to start to imagine they were seeing canals. So this was done just after the opposition of the planet. So it's no longer a perfect sphere, but oblate. And I got the template from WinJupos, which is a program you can use that will show you exactly what the exact shape of the planet would be at that time. Sketch I did of Mars, this opposition from Goat Mountain. I think maybe the fact that the lenses in my eyes are yellowing with age. I couldn't see quite the robust redness that I saw when I did this sketch. The seeing was not good. So I've labeled what I believe I found, but poor seeing. When I did this, the seeing was excellent. So again, with planetary observations, seeing makes all the difference. A sunspot that I sketched back in 2015, just using graphite. And then I'll just quickly show you the lunar sketches. Eratosthenes at sunset. This is all done with white pastel on black sketch paper. So no image reversing for this. This is a direct sketch at the eyepiece again, all done at the eyepiece. Sunrise at Copernicus, Endymion, and Rimae Hesiotis. Rimae, as you probably know on the moon, are these lines, that look like dried up riverbeds. They're either due to subsidence of the land, like cracks in some of the craters, or they could be collapsed lava tubes. I love finding the Rimae on the moon and sketching them. This was I worked on this Sarasota in Florida. Florida has some of the best seeing I've ever experienced with a telescope. Absolutely crystal clear, the Rimae that surround crater Triesnecker. Crater Wargentin, that's labeled C on this. This is an unusual crater in that it's lava filled. The crater rises above the surrounding area. And I just wanted to do a sketch of this, and I got to do it. There's also this strange Y formation of bright lines within the crater under high illumination as the sun, as this part of the moon, which is near the limb, gets sunlight. And this is another, this is a crater with a crater ray. Crater ray is the effect of the sun rising and the sun shining through a crack in the crater, creating a straight line of light right across the crater. I was happy that I was able to catch this at the tail end of the crater. Within about a half hour, that crater ray disappeared. Plato sunset, I fooled around with making an artistic mask. And the Guithuisan lunar domes, which are shield volcanoes labeled B and C, I had very good seeing. Again, the best view I've ever had of these two enigmatic looking structures on the moon. This is an actual photo of those two beautiful shield volcanoes. Rimae Ariadaeus and Rimae Hyginus on the moon. Again, two beautiful Rimae that become very visible with the rising sun or the setting sun. You can see them even even with a smaller aperture scope. I'd say a 6-inch would see these easily. And this area, very interesting. You see the crater labeled Keys, filled in with lava, and to the left of Keys Pi, that's again a lunar dome. So again, a lunar feature, extruded magma creating a dome, billions of years old, of course, on the moon. And that's it. So that's the end of the presentation.
Wow.
Randy,
That was awesome.
I have to acknowledge, I'm very impressed with your level of detail. And as you describe your drawings, I take it that the result is quite fragile. How do you protect your drawings from being damaged?
The lunar drawings, I try to put waxed paper between them to keep them from rubbing. The others, I'm just very careful. I put each one in a separate folder so that I've got them going back. As soon as my results started to improve a bit, I became very careful in saving them. So the graphite sketches are saved with each one in its own folder. And the lunar sketches have either tissue paper or wax paper between the sketches. And they last quite well.
That's impressive.
Randy,
Can you
there
stop
was
sharing?
a question about.
Hang on a minute,
Yes,
folks.
yes.
We're going a little long now, and I know there'll be other people asking some more questions. So could I ask everybody that has more questions to please type them into the chat area over there and make any other comments you wish to make. Meanwhile, we have promised people that we're going to be showing Orion time, and so we should get about showing Orion time. And then we will come back to Randy and talking about some more of the sketching stuff. Okay? So if we could do that, Molly, are you ready to take over?
Yeah, and as a reminder for the folks who are in the meet room, you guys won't be able to hear it through here. So if you want to listen to the music, you'll have to go over to YouTube.
Okay. Welcome to Orion Time. I'm Alex from the Astroimaging channel. On behalf of the volunteers who work hard to bring you our programs every Sunday night, I'm proud to present a collection of images made by members of the Astroimaging channel family. Some are highly polished products of expensive equipment, years of experience, and artistic gifts. Others are the proud early efforts of what we all were once, or still are, beginners, excited about what they can share with others of the beautiful night sky. We trust you will enjoy their efforts. Or still are, beginners, excited about what they can share with others of the beautiful night sky. We trust you will enjoy their efforts. Or still are, beginners, excited about what they can share with others of the beautiful night sky.
Terry, would you mute yourself so I could listen to it? Thanks.
do that. Excuse me, Randy's still here, so continue to put your questions in. I would just want to make a couple more comments about Orion time. I'm really pleased that y'all did that. It was a lot of work. One of the volunteers that we're looking for is somebody to go ahead and manage those programs from now on, because we are going to do another one of those programs. And of course, since spring is coming up, the next one will be called Gorgeous Galaxies. Okay, so Gorgeous Galaxies, and we figure by June 30th will be the time for that. We're going to rewrite the website a little bit to make it easier to turn those things in and make it easier to manage it. And you'll hear more about that next week. Also next week, one of the people, Jorge Restrepo from Mexico, turned in a 2.5-minute viaje in Orion. And we're going to be watching that. And I think you'll get a kick out of seeing that. Now, I think those were all my Orions. So thanks again for everybody who helped do that. Orion time. Now, who was it? Matthew Ray was asking for Randy. Randy, do you find using any particular filters are particularly useful? Which filters do you use when you're observing to do your imaging or to do your sketching? Turn yourself back on. You're muted. And you don't have to turn your share on to do this.
Sorry,
your mic is muted.
You're muted.
I got it.
You're back.
Yeah, I use an O3 filter and a UHC filter. That's about it. Oh no, I have a Bader moon glow sky glow filter, which is sometimes very useful because it adds a little bit of background darkness, and it doesn't make the image too dark. Sometimes I find with an O3 filter, the image is just too dark to work with. UHC filter is a little better, and the as I said, the Bader moon glow sky glow filter. That's it.
Okay, and what was the other question that Ray had?
Well, there was a question about using
White
a
Conte crayon.
dark material with a white drawing material or light colored drawing material.
White Conte crayon or something like that on black paper for the lunar sketches.
That's what I use.
Okay.
That's what I use. And the Conte, I mean, I could do a presentation on lunar sketching as well. The Conte crayons and Conte pencils have pastel in them, but they don't smear as easily as a regular soft pastel. So they're good to work with on black sketch paper. That's what all those lunar sketches were. None of those were reversed graphite or nothing like that. It's white on black sketch paper.
If I wanted to see you on cloudy nights, who are you on cloudy nights?
Randolph J.
Randolph J?
Yeah, and I have a lot of stuff on the sketching for him.
And that's your rap name?
Yes, Randolph J.
Randolph J. So when you do rap shows and stuff like that, it's
absolutely
weddings and things. Okay, cool. It's been a good night, and I know the sacrilege. Finally, I get somebody on the show to talk about sketching, and I give you 98 astro images at the end of it. Yeah, life's weird. Thank you very much, Randy. And next week, come on back, everybody. And Sean will be telling us about how to get the most out of storing our data, file formats, and all that other cool stuff. So thanks a lot, everybody. Good night.
Thank you. Good night.
Good night.
I'll take us out.
Red.